Welcome back to Lagom Effort Electronics channel, everybody, and I've had some requests both in comments on previous videos and IRL. If I could make a walkthrough video about Pi1541 and how to get it running, not on the Pi version 3, but specifically on the Pi 1 and perhaps more frequently on the Pi 0. So I thought I'd do that, and when it comes to the Raspberry Pi 0, the normal hat for the Raspberry Pi 3 will fit perfectly. And I do recommend getting a hat with the buttons on it and the display, because this sort of makes Pi1541 so much easier to control. Now, with Raspberry Pi 0 officially supported on Pi1541, we can expect to see some hats actually made for the Pi 0, but the ones available right now are a little bit of an experiment still, and I don't see them as a good replacement for the bigger hat that was designed for the B+ models. So I'm getting my Frankenstein's monster out, and it's turned into a bit of a favorite for me actually from the pile of Commodore 64s. And to get started with making an SD card for Pi1541, we find an empty FAT32 formatted card and plug it into our computer. I'll follow the instructions that are on the Pi1541 homepage, and it's basically a matter of downloading the binary package for the SD card, and that package only contains the kernel image file for Raspberry Pi 3, so we also need the Pi 0 specific version. And after getting that package, we need to go a bit further down and follow the instructions to see what other things we might need on the card. And specifically, that is the firmware package from Raspberry Pi Foundation, which is necessary to get the Raspberry functional at all. And once the firmware has loaded, the Pi1541 software will load in kernel. We also need some files from the Vice Commodore emulator for Windows. And I usually use the nightly builds, it doesn't matter. I think the files we need is the firmware image for the 1541 drive, and we might also need the character ROM for the Commodore 64. But these are, well, the firmware image is necessary, the character ROM is optional, but nevertheless we need to download the Vice application. Now we unzip all the files, and first we start with the Raspberry Pi Foundation firmware. And the instruction here say that we need to copy the boot code, the fixup, and the start ELF found in the firmware master directory boot. So we do that. There is fixup, boot code, and start ELF. All right. Next up, we put the Pi1541 distribution on it. Basically the Pi1541 zip file that we downloaded first. And that one contains 3 files and a directory. And then we take the kernel image file for Pi 0 and 1 and replace the one made for Pi 3 in the package. Inside the directory, which is basically the root directory of what will be the Pi1541 distribution, we have all the file browser applications for the various versions of the Commodore. And I'm only going to keep the file browser 64 because that's the only one interesting for me. I will also copy in 2 disk images. The Ghost and Goblins loader is known to be quite a difficult one, and it will be a good test to see if the Pi1541 actually stays cycle exact. And if it doesn't, it's going to have issues. So this is a very good game for us to test whether or not our overclocking for the 1 and 0 is enough. So starting with the Pi 0, I'm loading the config.txt, which is part of the firmware. And in that one, I will add some rows. This is actually on recommendation from Stephen White, these lines that will overclock the Pi 0 a little bit, about 10%. And that should be enough to give it enough headroom to have no issues with the emulation. Also, we need the ROM image for the 1541 because the Pi1541 will load an emulation of the drive. We need the firmware of the actual drive in here for it to run in the emulation. And it is also recommended, but definitely not necessary, to also put the character ROM from the Commodore 64. And this is not really supported on the Pi 0 yet. Might not ever be, but we'll put it here anyway. So those 2 files come from the Vice distribution. Now next up we need to edit the options file for Pi1541. And that is to adjust the settings to make it match our hat. Most hats need the setting split IEC lines equals 1 because they're designed from the option B schematics, which contain the 7406 circuit on it that splits the IEC lines between different I/O pins. Also, I will enable the use of the character ROM file to display the actual Commodore 64 fonts on the LCD and on the screen. But this is not supported on the Raspberry Pi 0, so it's not crucial right now. I'll do it anyway. Next we have the Gpio emulation of sound, which, I'll just leave it disabled, to be honest. We do need to set the LCD type here. And it's a matter of just uncommenting the correct LCD, controller and size. I recommend actually, this is a setting to use the Commodore fonts on the LCD. And the quick boot setting is to disable the delay at the startup logo so that it boots a bit quicker. The Gpio selections for the buttons is really on most hats, just following the defaults, so it's not a setting that you would need, but I think that's it actually. That's the file we need. Actually, no, there is one more thing. And that is here. Use lowercase file names while in browse mode. And I recommend that because otherwise all the capital letters will be shown as graphics characters and it will be very difficult to navigate, especially if you have all capital names. So that setting is important. Now, to summarize, split IEC lines is needed for the hat. I like the Chargen font, and I like to have lowercase browse file names. Then we set the LCD type, and we also what did we use? Yeah, the use Commodore characters on the LCD and the buttons, and that's it. That should be a good working distribution. So let's get the card in the Raspberry and see what happens. Yep, that booted all right. Let's see if it works then. Starting up the Commodore 64, the Frankenstein's Monster one, and I will load first the file browser 64 application. We're currently in browse mode, which means that we're accessing directly the SD card. And we can see the file browser working nicely. We have the two disk images here, but we can't see all of the file names, so it's a bit difficult to know which one to choose. One of them is a generic one, and one is made for the RAM expansion unit. So instead I will use the display on the hat, because that one would scroll the file names. This is the universal one, and that is the REU version. So I will mount this one. And now it's just like the floppy is plugged in, and it's now in emulation mode. So we'll start Ghosts and Goblins like it should be started, and we'll see how the fast loader in that game may or may not make it very difficult for us. Okay, it loaded, run. And what's happening now, the NOS-DOS loader is checking for the drive, and we can see it's running Commodore DOS. So it's actually emulating the drive now. And it has pushed in some code into the drive. And yeah, the fast loader is running. We'll see if we can start the game also. I know that, alright, I just remembered something. The PLA chip I have in this Frankenstein's Monster is not compatible with this game, so this is gonna fail. I think it's gonna hang now. Yep. That's it. Okay. I'll just switch to another Commodore 64, guys, and we'll be right back after the break or something. Isn't that what they say? You know, plug in the expected one instead. This is running in a short board with the Super PLA. So it's an original Commodore PLA in it. Let's see how that goes. Alright. Back to the same place as before when everything failed. Still running the Pi1541 on the Raspberry Pi Zero with our overclocking modification according to Stephen White's template. And that looks good. That looks very good. We'll start the game. It loads a bit more. And it's loaded. Okay then. Now next up, I'm going to see if we can just move this over to the Raspberry Pi 1. What we have is a Model B+, so it's 1.5 or something like that. The CPU is the same, or the system on chip is the same as the Raspberry Pi 1, but in the new form factor, so it's compatible with these hats. So running exactly the same setup, but with a Pi 1 instead of the Pi 0. And the Pi 1 has a lower core speed. And we can already see that this fails directly. So we need to put it back in the computer and modify the config text a little bit. Because The Raspberry Pi Zero is running on a higher core speed normally. And okay, now this is going to be a bit confusing. Core frequency in the config text means the GPU core and not necessarily the CPU core, because the ARM frequency is the CPU core. But the core of the GPU is also affecting the layer 2 cache and the memory bus performance. And it's running on about 400 for Pi 3 and Pi 0, but on the Pi 1 it's only 250. So that's why we need to overclock it for the layer 2 cache and memory bus to be comparable. We also set a temperature limit of 75 degrees because it is likely that the Raspberry Pi 1 will run a little hotter on these overclocking settings. But anyway, now with the GPU core set to 500, it should run more synchronously with the RAM, and it should be comparable to the Pi 0 at this point. But the Pi 0 would probably run a bit cooler. Sorry for the rambling and the M sounds. I'm not going to do much editing on this video to get it out quicker. Okay, loading and running is the moment of truth. Yeah, that's the load screen. Looking good. We'll press start and see if it loads the actual game also. It looks good actually, yeah. Let's see if it loads the last bit as well. And yeah, it seems to. So that's it, people. That's the walkthrough how to get Pi1541 running on the Raspberry Pi 1. And also, of course, the supported hardware, which is the Raspberry Pi 0. Between the file browser application and the buttons and display, there's really not much you need to worry about. But I'll show you how to create a new disk image, and you do it with a normal formatting command, like you would initialize a normal floppy disk on a 1541. I'll call it Kevin's Files, and right, I need to add to a character label here also, and make sure you're in browse mode, otherwise you will format the disk that is mounted. It's creating new disk, and it mounts it, and it's ready. And that's it. That's all you need to do to create new disk images on the Pi1541 from the Commodore. We can load the directory and see how it looks, just for fun. And the problem here that you already have seen, that this doesn't work very well with spaces in the disk label. But it works. So what's the benefit of using the Raspberry Pi 3 then? Well, it has a lot more power, so it can do more advanced things while still in emulation. And well, like for example the possibility to use the character set the font from the Commodore character ROM, and because it fits a lot more rows on the display. And also when you mount a disk image on the Raspberry 3, you can also see the current track being read or written, and that helps a lot, I think. On the other hand, the Raspberry Pi 0 is €6. It's hard to compete with that. So thanks for watching, people, and see you next time. Bye.